Hello, my name is Peter Clemenson. Welcome to the CIM export demo. In this demo, I will set up a mapping project, map a feature class to a CIM class, create relations between exported CIM classes, and do a test export to see the results of the mapping. Overall, the purpose of the program is to be able to convert data from a source system in JS to a file in CIM format. The source data is an SRI geodatabase. To be able to create a correct CIM file output that the receiver understands, I need to use the CIM profile that the receiver expects. Once I have the schema of the CIM profile and the source data, I can map between the two. With the mapping, I can start to do test exports to see and test the results of my mapping. The mapping between JS and the CIM profiles consists in essence of three different types of mappings. The feature mapping that maps between feature classes and CIM classes. The attribute mapping that maps between fields on a feature class and properties on a CIM class. And the association mapping that maps the relationships between CIM classes. In CIM, many of the classes are related to other classes. As an example, the disconnector is a type of conducting equipment, and the conducting equipment class has a relation to the base voltage class. In the demo, I will map the relation using an association mapping. To sum up, I will do the following in the demo. Set up a mapping project with source schema and target CIM profile, create two source definitions, create feature mappings between source definitions and CIM classes, create attribute mappings between fields in JS and properties in CIM, and create an association mapping to describe relations between two CIM classes. To get started, I create a new mapping project and give it a new name. I add the geodatabase to import data from. The program loads all feature classes and tables from that geodatabase. And I can browse the source data and see the subtypes and fields of the tables. Now I need to add the target CIM profile. I'll use a profile from NSOE in RDFS format. It is possible to browse the target CIM profile and view the properties and relations of the CIM classes. And that concludes setting up the export project and be ready for mapping. After setting up the project, the mapping between source and target begins. I start by creating source definitions that match the classes in the CIM profile. First, I create definition of disconnectors. Then I create the definition of base voltage. I can see how many features will be exported with the current scope of the mapping project. I also need some domain mappings. I can add my domain mappings using a mapping file or add them manually. I'll be using these domain mappings when we get to mapping towards the CIM profile. For instance, enable true in geodatabase will be mapped to normal open faults in CIM. Now I'm ready to start mapping between the source data described by source definitions and the target CIM model described as CIM classes. First I map the source definition of disconnectors to the disconnector class in CIM model. Then I map the definition of operating voltage to the base voltage in the CIM class. On the feature mapping, I can start to map individual attributes like global ID to MRID, and I map the facility ID to the name on the CIM class. For the normal open attribute on the CIM class, I want to use the enable field in the geodatabase. The enabled in JS and normal open in CIM needs a domain mapping to map correctly. Next, I map max continuous current in JS to rated current in CIM. This is also done using a domain mapping, since it is a domain in JS and a number in CIM. For the base voltage, I map from a table that I created based on the operating voltage domain in JS to base voltage in CIM. In that way, I get a base voltage for every possible operating voltage in JS. For good measure, I save my project before I move to the last type of mapping in this demo. The disconnector has a reference to a base voltage level or base voltage in CIM. To create that relationship in the CIM export, I need to create an association mapping between the disconnector and the base voltage. First, I choose which feature and property that will get the information about the relation. Then, I select how to match which features to get a relationship. In this case, I match the operating voltage of the disconnector against the code of the operating voltage class. I'm now ready to do a test migration with the new mapping. I have an extent or scope defined. All features inside that will be exported if they match the feature mappings. I need to choose an output file and give it a name. And press run. When I open the exported file, I can see that the overhead switches has been converted to disconnectors. The attributes are mapped for each feature, like global ID to MRID, max continuous current, enable to normal open, and max continuous current to rated current. The disconnector's base voltage was mapped using association mapping and points to another CIM object. The base voltage with the correct ID. That concludes the basic CIM export demo. To summarize, I have now created a mapping project with source schema and target CIM profile. I have created two source definitions. I have created feature mappings between source definitions and CIM classes. I have created attribute mappings between fields in JS and properties in CIM. I have created an association mapping to describe relations between two CIM classes. And I have exported a CIM file and viewed the result. Thank you for viewing this demo. I hope to see you again soon.